Hello students, today we are going to study one of the most important and most expected topic in JEE, Neet or any competitive exam, that is rotational motion. In the chapter of rotational motion, we will study about moment of inertia, radius of gyration, torque, kinetic energy of rotation and rolling motion. So today we are going to study moment of inertia. The moment of inertia of a body depends on mass and distribution of mass. More is the moment of inertia of a body, more amount of energy will be required to give rotational motion in the body. Okay. So how to define moment of inertia? It is a tensor quantity. The moment of inertia of a point mass whose distance from rotational axis is r. This is perpendicular distance, okay, about PQ. Then moment of inertia of this point mass is written as mr square. Its unit is kilogram meter square. Now, dear student, we are writing moment of inertia for point mass distribution system. Moment of inertia for point mass distribution system. Moment of inertia for point mass distribution system. Dear student, in the figure, some point masses have been shown about the rotational axis. Suppose this is M1, this is M2, this is M3, and this is Mn, whose perpendicular distance from rotational axis are R1, R2, R3 and Rn. The moment of inertia of given point mass distribution system about rotational axis PQ. The moment of inertia of given point mass distribution system about rotational axis PQ can be written as M1 R1 square plus M2 R2 square plus Mn Rn square. This can be written as summation mi Ri square, value of I ranging from 1 to n. Now, dear student, we will define one very important term, that is radius of gyration. What is radius of gyration? When complete equivalent mass either kept on right side or left side at perpendicular distance k from given rotation axis PQ, if we get, when we multiply by k square with total available mass, if we get same moment of inertia about the given mass distribution system, then this k is known as radius of gyration. So dear student, what is radius of gyration? The radius of gyration of a point mass distribution system or a continuous mass distribution system or a mixed mass distribution system is that perpendicular distance from given rotation axis whose square when multiplied by total available, remember this available word is very important, whose square when multiplied with total available mass of the system gives the same value of moment of inertia age is obtained by actual distribution of mass, then this K is known as radius of gyration. Okay, this K is known as radius of gyration. Hope you understood the meaning and concept of K. Hope you understood the meaning and concept of K. So dear student, let's calculate moment of inertia in some cases. Let us assume that 2 kg, 4 kg and 3 kg point masses have been kept at distance 1 meter, 2 meter and 3 meter from reference point O. Then find moment of inertia of this point mass distribution system about axis PQ, and also find radius of gyration. So dear student, what is moment of inertia? Of given point mass distribution system is 2 into 1 square plus 4 into 2 square plus 3 into 3 square. That will give us 2 plus 16 plus 27 . This is 45 kilogram meter square. This is the moment of inertia of point mass, given point mass distribution system about axis PQ. Now what about radius of gyration? Total available mass is how much? 2 plus 4 plus 3. This is 2 plus 4, 6 plus 3, 9. So we write 9k square. So dear student, k is what? 45 upon 9. This is 5. So k is plus minus root 5. Okay. So this is radius of gyration. Why it is plus minus? Because the point can be on right side or left side. Okay. So this is how we write the radius of gyration. Now dear student, we will be studying moment of inertia theorem, that is perpendicular axis theorem and parallel axis theorem. Okay. First understand why it's named as perpendicular axis theorem. The name of the theorem is perpendicular axis theorem because this theorem is used to determine, to transfer the value of moment of inertia from n axis to another axis lying in another perpendicular plane. Okay. Once again listen. The theorem is named as perpendicular axis theorem because the use of the theorem is to transfer the value of moment of inertia from an axis to another axis lying in perpendicular plane. Okay. Now listen the statement of the theorem. The statement of the theorem is I about zz dash equal to I about xx dash plus I about yy dash. Here xx dash and yy dash are the axes lying in the plane of the lamina, and IZZ dash is the axis passing through intersection point of the plane and perpendicular to the plane. Okay. Dear student, when mass distribution will be symmetrical, like in case of ring or disc, whenever mass distribution will be symmetrical, moment of inertia about xx dash and yy dash will remain same. Okay. For example, this we will be calculating little later, like moment of inertia of a circular ring of mass m and radius r about axis. Passing through its center of mass and perpendicular to its plane. Is given as mr square. And if we apply perpendicular theorem, so MR square will be equal to I xs dash plus Iy dash. Since mass distribution is symmetrical in ring, so moment of inertia about xs dash and Yy dash will remain same. So moment of inertia about xs dash or Yy dash in case of ring, this be equal to MR square upon 2. Okay. One more very important thing that you should remember. In the perpendicular theorem, the two axes lying in the plane need not to be perpendicular to each other. Okay. Why? Just see. Moment of inertia about xs dash or y dash, all about is mr square upon 2. Now, if we are marking this axis and this axis, diameter axis, this is also, suppose this is x1, x2 and this is y1, y2. So dear student, moment of inertia about x1, x2, y1, y2 is also mr square upon 2. So we can write this equation also in this way. I about xs dash plus I about x1, x2. This will also be equal to I about zz dash. Okay. So dear student, remember very important thing. In the perpendicular axis theorem, the two axes lying in the plane need not to be perpendicular to each other. Need not to be perpendicular to each other. Okay. Which axis remains perpendicular? The axis which passes through the intersection point of the two axes lying in the plane remains perpendicular to the axis. Okay. The zz dash axis remains perpendicular. Understood? So this is what perpendicular theorem. Now we will understand the concept of the parallel theorem. Dear student, why the name is parallel theorem? This theorem is used to transfer the moment of inertia from an axis to another parallel axis. But this theorem is applicable only when out of two parallel axes, one axis should pass through center of mass. One axis should pass through center of mass of the system. And also remember, moment of inertia of any system remains minimum. Moment of inertia of any system remains minimum about an axis passing through its center of mass. And the statement of the theorem is this. I about any axis, for example, xs dash, equal to I about center of mass plus mass of the body into square of the perpendicular distance between them. Okay. Dear student, always remember this theorem can be applied when out of two parallel axes, one axis should pass through the center of mass. And also remember, moment of inertia of the system remains minimum about an axis passing through the center of mass. Okay. Now let's see the question. A symmetric lamina of mass capital M consists of a square shape with a semicircular section over the edge of the square as shown in figure. The side of the square is 2a. The moment of inertia of the lamina about an axis through the center of mass and perpendicular to the plane is 1.6 ma square. The moment of inertia of the lamina about the tangent AB in the plane of the lamina, okay, that is very important. So dear student, how to solve this problem? This system is symmetrical, this is wrongly placed, this is okay. So moment of inertia of this system about an axis passing through its center of mass and perpendicular to its plane, we can write the equation like this. This is about zz dash. It is given in the question as 1.6 ma square. So dear student, moment of inertia about this axis which is parallel to AB from parallel axis theorem will be equal to 0.8 ma square. Now we are applying parallel axis theorem. Okay. So what moment of inertia about AB equal to moment of inertia about center of mass plus mass into distance between parallel axis square 2a square. So this will become 4.8 ma square. So dear student, this is the answer to the given question. Okay, this is the answer to the given question. Now you should remember some important formula for moment of inertia. Okay, like moment of inertia of circular disk. How to calculate this? This also we will see later. This you remember. Okay. Moment of inertia of circular disc. About an axis passing through its center of mass and perpendicular to its plane. Z means perpendicular. This is mr square upon 2, where r is the radius. Okay. Moment of inertia of solid sphere of mass m and radius r about center of mass is 2 upon 5 mr square. Moment of inertia of hollow sphere about an axis passing through its center of mass is 2 upon 3 mr square. Why it is more than the solid sphere? Because moment of inertia depends on the mass and distribution of mass. Okay, in case of solid sphere, hollow sphere, mass is located away from the center. Okay, dear student, moment of inertia of the thin rod of length L and mass m about center of mass is ml square upon 12, and about this extreme axis this will be ml square upon 3. You can find this by applying parallaxis theorem. Ml square upon 12 plus m into L by 2 whole square. Okay. So all these values of moment of inertia you need to remember, like moment of inertia of this square plate having mass m and dimension L about this axis in the plane. This is also ml square upon 12, and this is also passing through center of mass. This is also ml square upon 12, and moment of inertia axis passing through its center of mass and perpendicular to its plane. This is z dash. Okay, this is how much? This is ml square upon 6. This is how much? This is ml square upon 6. Okay. Okay, this is ml square upon 6. So dear student, let's see one important question, that how to transfer the value of moment of inertia, how to use parallaxis theorem. Suppose this is the case of a circular disc. This is the case of a circular disc. Of mass m and radius r. We have to determine moment of inertia about an axis passing through one of the point at its periphery and lying in its own plane. Lying in its own plane. Okay. How to calculate? Very simple. Dear student, moment of inertia of circular disc about an axis passing through its center of mass and perpendicular to its plane. This is mr square upon 2. So moment of inertia of circular disc about an axis passing through its center of mass and lying in its own plane. This is mr square upon 4. Now applying parallaxis theorem. Okay. So I about x1 x2 equal to I about center of mass plus m into r square. This is mr square upon 4 plus mr square. So dear student, this is how much? This is 5 by 4 mr square. So this is about x1 x2. If you talk about radius of gyration, make it equal to mk square. So k will be equal to what? In this situation, k will be equal to plus minus r root 5 upon 2. Okay. This is the value of radius of gyration. Let's see this question. The moment of inertia of a sphere is 20 kilogram meter square about the diameter. The moment of inertia about any tangent will be. Now, dear student, apply the parallaxis theorem. This is about diameter. Now we have to calculate about the tangent. This is PQ. So I about PQ equal to I about diameter. See, I about diameter is what? This is 2 upon 5 mr square. And what about I about tangent? I about tangent is what? 2 upon 5 mr square plus mr square. This is 7 upon 5 mr square. Dear student, this is given in the question is 20. So mr square is what? Mr square equal to 100 upon 2. This is equal to 50. So this is 7 upon 5 into 50. This is 70 kilogram meter square. Okay, so this is the answer. So dear student, out of 4 options, the option 1 is the correct choice. Okay, so answer is option 1. Option 1 is the correct answer. Now let's see this question. If the radius of gyration of solid sphere is 35 centimeter, the ratio of radius of gyration when the axis is along a diameter to that when the axis is along a tangent. Very simple. Radius of the solid sphere is given 35 centimeter. Okay, see here. The moment of inertia about diameter axis is what? 2 upon 5 mr square. And moment of inertia about the tangent axis for solid sphere is what? This is 2 upon 5 mr square plus mr square. This is 7 upon 5 mr square. And radius of gyration is what? mk square. Okay. So dear student, he is asking for a, if the radius of solid sphere is 35, radius of gyration when the axis is along the diameter to that when the axis is along a tangent. Okay, no issue. Here k square is what? 2 upon 5, 35 square. So here radius of gyration will be m k dash square. So dear student, m dash will get cancelled. So k dash square equal to what? 7 upon 5 r square. You divide these two equations. Okay. You divide these two equations. K dash square upon k square equal to what? 7 upon 5 upon 2 upon 5. This is 7 upon 2. And in the question, this k is given 35. Means k square is 35. Okay. So 7 upon 2 into 35. If the radius of the in question it is given radius of solid sphere is 35 centimeter. Radius of gyration when the axis is along a diameter to that when the axis is along a tangent. He is asking for ratio of radius of gyration. Ratio will be 7 upon 2 under root 7 upon 2. In question the language is not clear. Okay, dear student, no problem. If he asks for k dash upon k, the answer will be directly under root 7 upon 2. Okay. But in the question, it is given radius of solid sphere is 35 centimeter. So k square can be 2 upon 5 into 35 square. Ratio of radius of gyration when the axis is along a diameter to that when the axis is along a tangent. Ratio will be like this. K dash upon k, that will be equal to directly under root 7 upon 2. Okay. Under root 7 upon 2 is coming. You cut this. Cut with this 5 2 7. So this is the answer. Okay. So answer to the given question is option 2. Okay. Sometimes this type of confusion also come into picture. Okay. Dear student, k dash upon k is under root 7 upon 2. So the answer to the given question is option 2. Now look at this question. Adjoining diagram has 3 discs in which each has mass m and radius r. What is moment of inertia about axis PQ? See, this is tangential axis. This is also tangent. This is center mass axis. So about tangent, moment of inertia of the disc is mr square upon 4 plus mr square. Since these are 2 discs and the bottom disc is mr square upon 4. So total moment of inertia 5 by 4 mr square into 2 plus mr square upon 4. This is 10 by 4, 11 by 4 mr square. This is the answer to the question, okay? This is the answer to the question, okay? So dear student, this was something about moment of inertia. Moment of inertia is a very big section. Later on we will study many important questions on moment of inertia, application, cutting cavity question, okay? And in the next article we will start torque also, torque and angular momentum. Thank you very much.